Well, hi, hello, my dear students. Welcome to my video lecture class. Right up to now, I uploaded video lectures on the topic Newton's laws of motion. In this topic, I would like to discuss today contact forces. What is meant by contact forces? How many types of contact forces we had? And I explain each and every type with superb examples. Right, today's topic contact force. Okay, contact force. So contact force, what is the definition of contact force? First of all, whenever two bodies are in contact, the molecules at interface or boundary. Molecules at interface or boundary interact with each other. This interaction results net force results this interaction results developing net force. This net force is called contact force. So this net force is called contact force. So generally, simple definition, whenever two bodies are in contact, for example, this is one body, this is another body. So this is a interface or a boundary. This is a body 1. This is body 2. This is interface. So the molecules at this interface are interact with each other. This interaction results a net force developing in that. That net force is called contact force. Types of contact force. Are examples of contact force. 1. Tension force. 2. Friction force. 3. Normal force. Tension force, friction force, normal force. So these three forces mainly, so we discussed in this chapter. So these three forces are contact forces. While the two bodies are in contact, then only these three forces are developed. One is the tension force, second one is friction force, third one is normal force. So I explain one by one now. Here. First one is the normal force. The force which acts perpendicular to the surface. The force which acts perpendicular to the surface. Is called normal force. The force which acts perpendicular to the surface, perpendicular to the surface, is called normal force. Next, the second point, if one body is placed on another body, if one body now one body press the second body in one direction in this way, in the same way second body tries to push first body in opposite direction. For example, so this is one body. So this is body A, this is body B. So now body B pushes A in this direction. Similarly, A also pushes in this direction. This is like this, normal force is acting. Okay, normal force is acting like this. So A pushes the body B in one direction, B pushes the body in one direction. Okay, so this is a normal force. So now examples, we discuss examples, the best examples of normal force. Examples. Example 1. If one body placed on horizontal surface, so this is a surface I consider. So this is a body we are placing. So this is a weight mg. So this is a force F will be acting. This force is called normal force. This force is called, because the force which acts perpendicular to the surface. This is perpendicular to the surface. Is it or not? Surface of the body. Perpendicular to the surface of the body. That means here normal force is acts. Normal force always acts perpendicular to the surface of the body. Surface of the body. From this diagram, normal force N is equal to mg. Normal force N is equal to mg. So here mg means a weight of a body. Weight of the body. N means normal force. Normal force, right? Weight of the body, N means normal force. Next, application in the example 2, right? Next, example 2. Example 2. Example 2. If a body placed on inclined surface, So this is a block. This is a weight mg, it's acting like this, mg cos theta, here it is, mg cos theta. This is mg sin theta, mg sin theta. Okay, so this is a normal force m. So here is an angle, here is an angle, here is an angle theta, it is an angle theta. Okay, so whenever block is placed on inclined surface, at this case n is equal to mg cos theta, n is equal to mg cos theta. Here weight mg resolves into two components. One component mg sin theta parallel to inclined surface. Another component mg cos theta opposite to normal force. Mg cos theta acts opposite to normal force. Okay, so that's why n is equal to mg cos theta. Here normal force n is equal to, we take n is equal to mg cos theta. Like this, two types of we consider here. Next, this is about normal force. Next, we consider friction force. And tension force. First I discuss tension force, and again I discuss friction force. First I discuss friction force and again tension force. Second one is friction force. The force which opposes the movement of a body. The force which opposes the movement of a body. The force which opposes the movement of the body is called friction force. Friction force is always acts. Friction force is always acts opposite to the direction of a body. Opposite to the direction of movement of a body. Direction of movement of a body. So friction force is depends on nature of surface, but normal force is independent upon nature of surface. Independent upon nature of surface. Independent upon nature of surface. Friction produces heat. Friction produces heat. Friction is directly proportional to roughness of a body. Roughness of the body. Roughness of the body. And friction inversely proportional to friction inversely proportional to smoothness. Smoothness of the body. Smoothness of your body. Okay. So this is about friction force. For example, if I consider a body here, body moves in this direction, applied force in this direction. So then frictional force will be acts in opposite direction. This friction force F is equal to mu into N. Friction force F is equal to mu into N. Here mu means coefficient of friction. N means normal force. N means normal force. So friction force F is equal to mu into N. Mu means coefficient of friction. N means normal force here. Okay. N means normal force. So this is about two important types of contact force. One is we discussed friction force, and another one is normal force. In next lecture I'll discuss about tension force. Okay, so I'll explain in next lecture tension force. So I hope you understood this lecture. If you will get any doubt, please mention in comment box. Thank you for encouraging me. Thank you for watching my lectures. Thank you so much.